Hey there. We are Algebra 2, Chapter 1, Lesson 9. Lesson 9's title is Graph and Solve Quadratic Inequalities, right? If you remember, inequalities are greater than and less than. They're no longer equalities or equations, they are inequalities. And with inequalities, that's where we learned how to shade things. In Algebra 1, I should have gotten a new page. Oh, wait. Sorry. In Algebra 1, I'm not even plugged in. My tablet's not working. So sorry. There we go. Let's see. We learned greater than or less than was a solid line, or less than or equal. Sorry. Less than or equal to, greater than or equal to, we draw solid lines. Less than or greater than, we do dashed lines. And then we shade above a line or below a line, depending on how it's set up. But erasing. But we'll review that when we go through the quadratic inequalities. There we go. Okay, so let's read this. A quadratic inequality in two variables can be written in one of the following forms. Notice the y is first, so y less than or equal to, greater than or equal to. The graph of any such inequality consists of all solutions of the inequality. Our equation's going to include infinitely many solutions, right? So to graph a quadratic inequality in two variables, that means x and y. First, we're going to graph the parabola, like old school, like we've been learning all chapter, and make the parabola dashed if it's less than or greater than, and solid if it's less than or equal to or greater than or equal to. So when we graph the parabola, we're going to graph it like this. My phone's ringing. I don't answer it. It's just going to be loud. Sorry. Okay, so that's what we mean by dashed and solid. So then, just like linearly, we test a point. We would test a point in the inside of the parabola by plugging it into the equation. We test a point. A point is an ordered pair, x comma y. We plug it into the equation and we see if it is a true statement or not. So test a point inside the parabola to determine whether the point is a solution to the inequality. If it makes the inequality true, then it is a point. If it makes the inequality false, it's not a point. And then shade the region in the parabola if the point is a solution, shade the region outside the parabola if it's not a solution, okay? If you guys remember, my favorite test point is 0, 0 because it makes math really simple. So if you can test 0, 0, please do. If 0, 0 is your vertex, you can't test it because that's on the parabola, okay? Let's move on. All right, so graph this parabola. The first thing we're going to do is, graph this inequality. First thing we're going to do is graph the actual parabola. We've learned lots of different ways to do this. You can, let's make it an equation. You can factor it, x plus 4, x minus 1. That'll give you your two x-intercepts. And then plot those. -4 and 1. You can also graph the y-intercept, which is -4, and then reflect it. But we don't know where the line of, or the axis of symmetry is yet. We do -4 plus 1 over 2. We get -3/2. Icky. 1, 2, there we go. So the axis of symmetry is right there. I'm not going to be able to draw that very well, sorry. And then I can reflect the y intercept over. And now I have enough points. Well, no, I don't. So the vertex is going to be that x value, and then you have to figure out what the y value is. So that's the y value of the vertex, and that's going to be, I don't have the actual one, down here. Okay. 9/4 plus 9/2 minus 4. Yep. 9/4 plus 9/2 minus 4. 2.75 or 11/4. 2.75. So negative 1/2. 1, 2. That doesn't make sense. Oh, my bad. Making another mistake. Doing fantastic. So that's a minus. So let's fix that. There we go. Negative 6.25. 1, 2, 3, 4, 5, 6.25. Okay, so we have enough to draw. Now we have to test our point. Okay, let's test our point. I am going to test 0, 0 because that is inside the parabola. So put in 0 for y, 0 for x, minus 4. Is 0 greater than negative 4? Yes, yes it is. So that's why we shade inside of our dashed line parabola. Another example. So, right, or using a quadratic inequality in real life. Rappelling. A manila rope used for rappelling down a cliff can safely support a weight provided where D is the rope's diameter in inches. Graph the inequality. So here we have a bit simpler of an equation. So let's work with it. I have W is less than or equal to 1480 D squared. I graph that. Let's use Desmos for this one. 1480, but I have to use x squared. Oh, my face needs to be moved. Let's see. Let me get a good. If I click on the wrench, I can get a good. Hold on. Sorry, one of my kids needed something. All right, so I'm going to change my x and y axis. Always takes me too long. And I did it backwards. Will you believe that? Yes, Carly, Miss Carly, we do believe that. So there's our graph, okay? It's a real life example. So what this means is the diameter of the rope, it's gonna go from 0 to, in my case, I set my x-axis to go up to 3, but it looks like for what we can read, the diameter of a rope can go anywhere from 0 to about 1.5, okay? And that means the weight that we can, let's see, where W is the weight in pounds, safely support the weight in pounds. It looks like it's pretty heavy, like it'll support quite a bit of weight. Now, this is an inequality. So are we going to shade above or below that inequality? So if I go here, our graph looks something like this. It's a solid line. Granted, it really goes on this side too, but that's just silly because in a real life situation, we are never going to have a diameter of rope that's negative. So we don't want to shade the negative part. Okay, we only shade the positive part of the parabola because the diameter of our rope will never be negative. Now, so really our graph would look like this. Oh, that's not what I wanted to do. Sorry, need that y-axis back. So do we want to shade above or below the line? I bet intuitively you can figure it out, but we're still going to test a point. I'm going to test 1, 1 because, okay, 1, 1 is over. No, let's see. Let's test a bigger point. Okay, if you go back to the Desmos, you can see that that is a point. That'll be easier for me to do. I can graph 1, 2,000 right there, so I know it is on the inside of the parabola. Let's go ahead and put it in here to test it. The x-axis is actually the diameter, so that's going to be 1 squared times 1480. Is 2,000 less than 1480? No. So we're actually going to shade below. Okay. So that means as our diameter increases, the weight is just the weight underneath it. Okay, that is what makes this inequality a true inequality. And there we go. We used the same point they did. All right, so now we've talked about single inequality equations. We can actually talk about systems of inequality equations too. A system is more than one equation. We've done systems of equations in Algebra 1, and that's where we have multiple lines that cross, and where they meet is the solution. Or systems of inequalities, linear inequalities. You know, we would shade below, we would shade above, and then the actual solution is where they overlap in that area right there. Okay, that's the solution. So this would be equalities, linear equalities, and then linear inequalities. Parabolas are the same, okay? I can actually do system of parabolas where they cross in 2 spots. Okay, somewhat of a bad example because the 2 spots should be symmetrical. And I can also do a system of inequalities for parabolas where, say, this one shades above, this one shades below, so the final answer would be where they overlap, just like in the linear inequalities. Right, that's what we're going to do now. To read this together, graphing a system of quadratic inequalities is similar to graphing a system of linear inequalities. First graph each inequality in the system, then identify the region in the coordinate plane common to all the graphs. This region is called the graph of the system. So really big words for where do they overlap. That's what you want. Where do they overlap? So graph a system of quadratic inequalities. So we have 2 quadratic inequalities. I'm going to graph the actual inequalities first. Y equals negative x squared plus 4. So to graph it, I'm going to set it equal to 0 and then factor out okay, and then I can divide both sides by negative 1. And I have 0 equals x squared minus 4, which I know factors into x plus 2, x minus 2. Okay, that's one way to graph it. I know it's going to cross the x-axis at negative 2 and positive 2. Another way to graph it, it's in vertex form, actually. This is how we first learned how to graph these things. That means it's a parent function. It opens down, but it has shifted 4 units up. 1, 2, 3, 4. Okay, so it's this one, but we see that it does cross the x-axis at 2 and negative 2. So if you had attacked the problem this way, you would have been fine. If you attacked the problem this way, you would have been fine. Okay, this is a solid line because it's less than or equal to, and I'm going to go ahead and test the origin, 0, 0. 0 less than or equal to negative 0 squared plus 4. Is 0 less than or equal to 4? Yes, which is why we have shaded underneath this parabola. Now let's try the other one. Let's graph it. I'm going to factor it first. X minus 3, x plus 1. You guys can still work through the methods we're learning because we would do the negative 3, what multiplies to negative 3 and adds to negative 2. And I would get 1 times 3, but I need the 3 to be negative. So when I add those together, which is how I did this. So my x-intercepts are 3 and negative 1. So to find the axis of symmetry, I get 3 plus negative 1 over 2. So that's 2 over 2, which is 1. Plug that in. 1 squared minus 2 times 1 minus 3. 1 minus 2 minus 3 is negative 5, negative 4. So my vertex is 1 comma negative 4. So let's try it. Okay, over 1, down 4. Let's change colors. That one looks pretty bright. Over 1, down 4, we have the vertex. We have x-intercepts, positive 3, negative 1. It's a dashed line. And let's test a point. I can test 0, 0. That makes me so happy. Is 0 greater than negative 3? Yes, it is, which is why we're shading in the inside, which is already shaded there. But the actual solution is going to be where they overlap, which is that part. Okay, that's the actual solution. And the only way to show me that you understand things like this is graphically. You can't say, hey, Miss Carly, the answer's 2. You can't. You can only show me graphically, okay? More room. And then guided practice, okay? Let's see. It says to see the margin. I don't see the margin. All right, so let's go ahead and see what we can do. I have the graphical solution there, but let's see how we got it. You can put this into vertex form and graph it. You can find the x-intercepts and graph it. Whatever makes sense to you is going to be the easiest. So go ahead and let's see. I think 2 times 4, x plus 4, x minus 2. Yep, that'll work. So my x-intercepts are negative 4 and 2. Axis of symmetry. Add those two together and divide by 2. X equals negative 1 is the axis of symmetry. Vertex. This may not be the easiest method, but this is the one my head usually goes to. So negative 1 squared plus 2x, nope. Plus 2 times negative 1 minus 8. So 1 minus 2 minus 8, 8, 9, 10 equals 9. Negative 1, 9. 1, 2, 3, 4. 2, 4, 6, 8, 9. Vertex. X-intercepts, a positive 2, a negative 4. Y-intercept, negative 8, reflected over. It's a dashed line because it's just greater than, and let's test a point. I can test 0, 0. Is 0 greater than negative 8? Yes. So our solution is shaded on the inside with a dashed line. Right? Next one. Okay, not as easy to factor, is it? Let's see if I can still do it. It's going to give me messy answers for factoring. So I'm going to go straight to the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c. So I have all over 2a. So I get 3 plus or minus the square root of 4 times 2 is 8. Oh, all over 4. So 3 plus or minus 1 over 4 is 1. That would be 3 plus 1 over 4 is 4 over 4. Or 3 minus 1 over 4 is 2 over 4, which is 1/2. A little easier than I thought. It's okay though. It was so small, I just couldn't, yeah. So those are my two x-intercepts. My axis of symmetry, and my head's getting ahead of mine. If I add those together and divide by 2, 3/2 over 2 is 6/2, which is 3. No, let's see. 2/2 plus 1/2 is 3/2 over 2. That'd be 3/2 times 1/2, because to divide fractions, you multiply the reciprocal. Ooh, I already did it. Equals 3/4. That is my axis of symmetry. To find the vertex, oh golly, this one's getting hard, isn't it? Not hard, just tedious. I need the y value. I'm getting out my calculator. 3/4 squared minus 3 plus 1. 2 times 3/4 squared minus 3 times 3/4 plus 1. Negative 0.125. So my vertex is 3/4 comma negative 0.125, which is right there. All right, so we've drawn it. We have a solid line and we test a point. I'm still going to test 0, 0. Okay, so 0 less than or equal to 1. Is 0 smaller than 1? Yes, but look, 0 is on the outside this time, so we shade everything on the outside. Okay, graphing it, just going to show you what we should do when we have a negative leading. I factor out the negative and then divide both sides by -1. X squared minus 4x minus 2. I don't have whole numbers for answers for this one either. So you can use the quadratic formula. Okay, let's practice this one in Desmos. Just because we can. Let's see, I've already lost the problem. Y equals, I'm going to show you a trick with this too, negative x squared plus 4x plus 2. What's really important here is that's really easy to graph, but if I ever give you an assessment or I'm grading something, you're going to have to show your steps to get the full credit, okay? Because this is too simple. What's really cool is I can actually do an inequality. I can click in less than, and it's going to shade it for you. Okay, all the coolness. I can do less than or equal to by just typing the less than sign and then the equal to sign, and it'll make it solid. I can put 2 of them in here. Y is greater than x squared, and it'll show you the overlapping. Okay, Desmos is pretty cool for inequalities too. And that was the graph that Desmos showed. All right. System for inequalities. For this one, I have the parent function. which is just at the origin. And here, this is vertex form, so it's easier. That means open down. And this means shift 5 up, which is what we've done right there. Okay, now test a point. I can test 0, 0 for this one. Is 0 less than 5? Yes, which is why I'm shading underneath it. I can't test 0, 0 for that one because that's on the curve. So I can test 0, 1. X, Y, is 1 greater than or equal to 0? Yes, so we're going to shade above it. Pretty easy guided practice on that one. And we're going to stop here, and I will continue the lesson in a little bit.